Alright, let's take a look at the graphs of y equals sine x, y equals cosine x. We're going to do all sorts of things to them today. First, I want to start off with the basic functions themselves. They both have a period of 2 pi, and if we split that 4 ways, split it in half, we have pi. Split that in half, we have pi over 2. So it would be 3 pi over 2. And if we look at the sign, we know that the sine of 0 is 0. And we know that sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi, 0 again. And we look at cosine. Now the cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. 3 pi over 2 is 0. 2 pi is 1. So they both go from maximums through to an intercept to a minimum and so on and so forth. So like sine, we have intercept, max, intercept, min, intercept, and it would repeat. In cosine, we have max, intercept, min, intercept, max, and it would repeat. It's the very basic sine and cosine function. Let me introduce something else to it. Make a number out front. In this case, we have y equals 2 sine x. It's going to behave the same way, as in it's going to go intercept max, intercept min, intercept max, intercept min. But those maximums and those minimums are going to change because this number right here is known as the amplitude. It says how far it varies from the x-axis. So the amplitude of 2, its max is going to be 2, its min is going to be negative 2, its period is still 2 pi, and it's going to go intercept, max, intercept, min, intercept, max, intercept, minimum. Same would be true for cosine. It would look basically the same, but it would be either vertically stretched or shrunk. Introduce something else. So we have 2 times the sine of x over 2. And we want to draw a sketch of this. Two is our amplitude. So it's going to go from positive 2 to negative 2. Now its period is going to be determined by that. X over 2 could be rewritten as 1/2 x. And our period, or the time in which it repeats itself, is 2 pi over b. B being the number that is beside the variable x. So in this case, our period is 2 pi over 1/2. What's 2 pi over 1/2? It is 4 pi. So we have an amplitude of 2 and a period of 4 pi. And what we need to do is in order to graph this and find the critical points where it hits maximums and intercepts, we need to divide this period into 4 parts. we divide 4 pi by 4 parts, we have intervals of pi. So starting here at 0, we have 1 pi, 2 pi, 3 pi, 4 pi. Started with 0, and I kept adding my intervals of pi until I got to the end of its period. And then because it's sine, it's going to start an intercept, and it's going to do exactly what sine has been doing since we started this thing, and it's going to go maximum, intercept, minimum, intercept, maximum, intercept, minimum, intercept. Introduce something else. Let's go 1/2 cosine x minus pi over 3. This is getting totally crazy. My amplitude is 1/2. My period is 2 pi over b. B is the number beside x, and that in this case it is just 1. So the period is 2 pi. But what has happened here is that the graph has been shifted left or right. It's been shifted horizontally. So we need to determine when a period starts and ends. And you can find endpoints because they are given by taking what's inside the parentheses and setting them equal to 0 and 2 pi. So what is in the parentheses? X minus pi over 3. So you're going to set x minus pi over 3 equal to 0. You're going to set x minus pi over 3 equal to 2 pi, and we're going to find values of x where the period begins and ends. So in this case, x is pi over 3, and over here x is 2 pi plus pi over 3, which would be 6 pi over 3 plus 1 pi over 3 would be 7 pi over 3. So it begins at pi over 3 and ends at 7 pi over 3. And if we take the period and split it into 4 parts, that is intervals of pi over 2. Now in the originals we started with 0 because there was no horizontal shift, and there we go, and we added intervals of pi over 2 plus pi over 2 plus pi over 2 until we got to the end of the period at 2 pi. So we're going to do the same thing here, but we're going to start, instead of 0, we're going to start at pi over 3. And our amplitude was 1/2 and our split is pi over 2. So we're going to add pi over 3. We're going to take pi over 3 and we're going to add pi over 2 to that. Let's see. Should we write these? I have to turn those into sixth. 2 pi over 6 plus 3 pi over 6 is going to give us 5 pi over 6. And we're going to have to add another pi over 2, or 3 pi over 6. That's going to give us 8 pi over 6, which is going to be 4 pi over 3. And we're going to have to add another pi over 2. So we had 8 pi over 6 plus another 3 pi over 6, 11. Wait, what did I just do? Yeah, 11 pi over 6. Add another 3 pi over 6, 14 pi over 6, which, when simplified, is 7 pi over 3. So we ended up at our last endpoint by starting at pi over 3 and adding our intervals of pi over 2. And this was a cosine, maybe? Yes. So it's a cosine, so we started at a max. Our min, max. Groovy stuff. Following those examples ought to get you through the stuff on page 4, 11, and 12. And you should be able to graph any sine or cosine function that I throw your way.